Hi there, this video is going to talk about learning target number 3, and that is I can classify a number as rational or irrational. So let's get going. Turning your notes packet to learning target 3, classifying numbers as rational or irrational is our objective for today. So first of all, we're going to talk about the real number system. So up here on this top line, right here, all of these numbers in the box are called real numbers. So we're going to put real up here, real numbers. Now there are such things as complex or imaginary numbers, but that's something that we study later on in math, in the higher level math classes. So this is real number system that we're talking about, and all of the numbers that we deal with in this class are real numbers. I just wanted to clean that word up a little bit. Now, within the real number system we have two broad categories, and the first category is rational numbers, and the second category is irrational. So let's talk about the difference. A rational number, and I'm reading along with you, a rational number is any number that can be written as a fraction. This is what we took notes on earlier. A and B are integers, and B cannot equal 0. So in decimal form, we can write them as terminating or as repeating decimals, and that's what we worked on with learning target 2. The other category is called irrational, and these numbers in decimal form do not repeat and do not ever stop, so they go on forever in decimal form. Once we identify something as irrational, there's no other categories it will fall into. But rational numbers can be broken down even further into 3 more categories. Notice that this box is outside of all of the other 3 boxes. So that means if it's in the orange box here, it is also in the green box, so anything in the orange box is a rational number, as well as an integer, and we have talked about integers already. Integers are whole numbers and their opposites, which means they don't have any parts when they are simplified. So I'm going to just draw in here some examples of integers. -10 doesn't have any parts, -3 doesn't have any parts, 0 doesn't have any parts, 5 doesn't have any parts, and 2000 doesn't have any parts. So these are positive and negative numbers, but they don't have any decimals or fractions in them when simplified. Now, if I do something like 15 over 3, some people might think, well, that's a fraction, so it has parts. But remember, we have to simplify that first. And 15 over 3 means 15 divided by 3, which is 5. And 5 doesn't have any parts. So we would say that 15 over 3 is an integer. Moving on to the next category in blue, numbers that start at 0 and go up but don't have any parts. So we're talking about numbers 0, 1, 2, 3, and that goes on forever. Those are called whole numbers. And then in the purple box at the bottom there, these numbers are almost identical to whole numbers, but they don't include the 0. So they start at 1 and go up. 1, 2, 3, etc. So numbers that don't include 0, but don't have any parts and are only positive, we call those natural or counting numbers. So what you need to know is that when we talk about numbers in this class, the numbers will be in one of two categories. They will either be rational numbers or irrational numbers. If it's a rational number, again, it could be an integer, a whole number, or a natural number. If it's a natural number, notice I have the number 3 here, but I also have it up here. 3 would also fall under the category of integers, and 3 would also be considered a rational number. So if there is a number down here in this list, it actually belongs in all categories on the left-hand side of the big green box. Let's move on to some more problems. I just talked about rational and irrational numbers in decimal form never end and never repeat. But sometimes we have numbers that are not in decimal form and they are in square root form, or radical form is another way to say that. So let's talk about what happens then. Alright, so please go ahead and fill in the blanks while I discuss this. It says in the top box that the square root of a radicand that is a perfect square is rational. So this is a bunch of vocabulary that we've already talked about in previous videos. Let's remind ourselves, if we have a square root, the radicand is the number under the square root. So let's say we have the square root of 25. The radicand is 25. So since 25 is a perfect square, the square root of 25 is rational. So a rational number occurs when we try to take the square root of a perfect square. In the next box, it says the square root of a radicand that is not a perfect square is irrational. So let's think of a number that is not a perfect square. So in the previous videos, we did perfect squares were 0, 1, 4, 9, 16, etc. So let's pick a number between 4 and 9 because those two are perfect squares. Let's do the square root of 5. If we take the square root of 5, since the radicand is the 5, and 5 is not a perfect square, this is an irrational number. So let's compare these lists. Rational numbers can be fractions. They can be terminating decimals, which means decimals that end, or repeating decimals, decimals that have the same number or numbers repeat. Or they can be square roots of perfect squares. Now let's compare that to irrational numbers. And irrational numbers are, in decimal form, either non-terminating, or I'm sorry, they are both non-terminating and non-repeating decimals. If it's in radical form, it would be the square root of non-perfect squares. Alright, now in this last example that you have on your notes here, we have to identify if each number is rational by putting an R in the box next to it, or irrational. So the list that you have written down on your notes, right above there, should help you out. What I'm going to do is have you pause the video, and then when you are done filling out this chart, start the video back up to see if you were right. Again, please pause the video now. Alright, here are the answers, so check your answers, and my guess is that you might have some questions because you got some of these wrong. This is a perfect opportunity for you to ask either me or Mr. Zingery to explain the answers that you got wrong. And that ends the video. Take care.